Okay, so we're here. We have an equation 3t squared minus 6t plus 3 equals 0. And we want to find all possible values of t that make this equation true. So we'll notice some very apparent differences between this problem and the last one. First of all, we see that it's t instead of x. Again, don't be fazed by that. Totally fine. You can use any variable. Doesn't matter. You treat it the same. Secondly, we notice that this coefficient up here isn't 1. So right off the bat, this might actually be a little bit harder to factor than our previous problem. But what you'll notice is that each of these is actually divisible by 3, right? So we can very quickly just simplify this. How? Just divide this whole thing, divide both sides by 3. So that means dividing every term on this side by 3 and every term on this side by 3. So what would you get? Here you'd get 3t squared over 3, so that's just t squared, right? Minus 6t over 3, so minus 2t. And then 3 over 3, so just plus 1, right? So we divided each term here by 3 to simplify it. So I divided it by 3 because I want this first one to be 1, this first coefficient, so that I can more easily factor it. And what will it equal? 0 over 3. We don't have any more terms. 0 over 3 is still just 0, right? So that's the cool part. You can just divide it out. This stays 0, and you get a more simple version. Okay. So now we're looking at t squared minus 2t plus 1 equals 0. What are we trying to do? Same thing as last time. We want to find two numbers that add to get negative 2 and multiply to get positive 1. So what would that be? Well, I think negative 1 and 1 work, right? So again, sometimes with the negatives it's a little bit tricky, but no problem. So just again, once you crunch a few of these, you'll get better and better and faster at doing it. So negative 2 is negative 1 plus negative 1, also known as negative 1 minus 1, right? So that's negative 2, and negative 1 times negative 1 is positive 1. So those are our two values. So where do we go from here? So just like in the last example, you can rewrite this as two factors. Again, two things that multiply together. In this case, we decided that negative 1 and negative 1 are our two numbers that make this equation work. So we can rewrite this as t minus 1, because we said it's negative 1, right? T minus 1 times t minus 1 equals 0. Again, if you want to just check yourself real quick, multiply it through, right? So t times t plus t times negative 1, then negative 1 times t plus negative 1 times negative 1. So that would be t squared minus t plus 1, so it would be t squared minus 2t plus 1. So this works. The conversion is good. So what do we do at this stage? Again, just like last time, if either one of these, if either this factor or this factor are equal to 0, then this whole thing is equal to 0, which makes the equation true, right? So again, we set each of these individually equal to 0 to find what t value makes that factor 0. So we'd have t minus 1, like that, right? And so I'm not being dumb. I realize that they're the exact same. You'll get the same t value. I'm trying to illustrate a point. So plus 1 plus 1. So t equals 1. T equals 1. Okay, so we got the same value for both. What does that mean? All that means is that for this particular equation, there's actually only one solution. Last time we had 2. This time we had 1. That's totally fine. Quadratics can have either two solutions, one solution, or some of them can actually have no solutions, but we're not dealing with that. So our only solution is t is equal to 1. Again, if you want to test it out, you can plug this back into either this one or this one. Both will work, right? We just simplified it. So if you plug 1 back into it, 1 squared, so 1 minus 2 times 1, so 1 minus 2 plus 1, 0. So there we go. And what did we see different in this equation? Again, as opposed to last time, we didn't have a first coefficient equal to 1, but that's fine. We just dealt with that by just dividing everything by that coefficient. Now, that won't always work. Sometimes you don't have stuff that's divisible by that first one, and that's a little bit problematic, but we'll get to that. So in this case, it works out very nicely. So we divided everything by 3 and factored from there like we did before. So is there any time that factoring won't work? Yes, actually. So why don't we get to an example like that?